And you know where to find the recordings now, right?
Yes.
So here we go. So we have an exponential function which we know y is equal to e to the x power, right? That's an exponential function. Doesn't have to be e, but generally we use e in math. It's one of the simplest exponential function. No, sometimes we don't only have x here. Sometimes there's more than, it could be x plus 2 or 3x plus 5, or, y is equal to e to the x plus 2, or y is equal to e to the x squared plus 5x. We can have anything in the exponent. It doesn't have to be just x. But these are all examples of exponential function. When it has more than just x, like x plus 2 and x squared plus 5x, they normally refer this to u as u. So our u is actually whatever the exponent is in all these problems. Are we clear with that? So our u, once again, is the exponent. So for u is equal to x plus 2, let's take the derivative of this. We're going to find du, not y, because this function doesn't have y. So when we take the derivative, it's going to be du by dx. On the left side, what do we get on the right side? What's the derivative of x plus 2? What? These guys are participating, but be careful because you need to know derivative all throughout the class. Let's go back to the derivative of x. The derivative of x is just 1, right? Thanks, Louis. 1, 1, 1 for emphasis, right? And the derivative of 2 is going to be equal to 0. So this goes away. You guys remember to find derivative, right? X is x to the 1, so we're going to move 1 to the front and subtract 1 from it. So this becomes 1x to the 0, which is x to the 0 itself is 1. So this is 1 times 1. So the derivative is equal to 1. You guys can't afford to, not remember this stuff, because this textbook builds on everything you have learned in the previous chapter. And please do not wait until the last minute to do the assignments, because a lot of you didn't do the practice test because you ran out of time. All right, let's make the next one. Let's review derivative x squared plus 5x. Let's say, for example, our u is equal to x squared plus 5x. What is the derivative of this? What is du by dx?
X plus 5.
What was that?
2x plus 5. Sorry.
2x plus 5? I thought you said x plus 5. So it's 2x plus 5. I agree. How about if our u is equal to 1, let's say 2 over x to the 4th power? Where's Fate? So Louis, is that the derivative?
I think so, yeah.
Anyone else?
I may be wrong.
But you're on the right track. It's not wrong, it's incomplete at this stage. But definitely on the right track. Michael says negative 8x to the negative 5. Or over x to the 5th. All right, I'll buy.
I just rewrote it. It's 2.
Right, so it was a rewrite, so it's still u, right? That's not a derivative. It's 2 times x to the negative 4th.
So the derivative is
Derivative is what Michael has on the board.
negative 8. Yeah, I see.
So du by dx is equal to negative 8x to the negative 5, or negative 8 over x to the 5th. Let's do one more. How about if u is equal to the cube root of x squared plus 3? Anyone? What are we going to do with this?
Do we use the chain rule?
We are going to use the chain rule, but what do we have to do first?
Rewrite.
We're going to rewrite it. And you agree? So the rewrite on this would be x squared plus 3 to the 1/3 power. Do we agree with that, Jane?
Yes.
All right, so now we're ready to take the derivative. And I don't know why I wrote y there. I'm trying to write u. So the derivative then, u prime or du by dx, would be equal to 1/3 times this. We keep the inside. We subtract 1 from the exponent, which makes it negative 2/3. And we still have to do something else for the chain rule. What else do we have to do?
Find the derivative of the inside.
Find the derivative of the inside. Thank you very much. And the derivative of the inside would be 2x. So this could be 2x on the front over 3 times x squared plus 3 to the negative 2/3 power, or 2x over 3 times x squared plus 3 to the 2/3 power on the bottom. Pull up your homework. All right, any questions on that before I start? That was more of a review of all the rules. So let's go back up to our rule. It says if we take the derivative of an exponential function, where the exponent is u, then the derivative is e to the u, so we're keeping the original function and times it by the derivative of the exponent, which is du by dx, which is what we're just doing. So if we take a derivative of the exponential function with u, we keep the function and multiply by the derivative of the exponent. Is everyone clear with that? So in my MATLAB the first question in your homework says f of x is equal to e to the 12x. Find the derivative of that. So f prime of x is a derivative on the left side. What is our u in this problem?
12x.
Our u is 12x. I agree. Right, so if our u is 12x, what is du by dx? What is the derivative of 12x? Excuse me. 12, 12, 12, 12. Sounds good. Don, you agree with the 12?
What was that?
You had a 144x. You're
Oh,
not sure.
I was trying to solve the whole thing.
Okay. All right, so on this, so this is 12 for the u, right? And this is our u all the time up here. So what does the rule says? Let's go back to the rule at the top. It says keep the original function, which is e to the 12x, and multiply it by what? Du by dx. So this would be times 12. So all the rule is the same. We just keep the function and multiply by the derivative of the exponent. So this becomes 12 times e to the 12x. That's our derivative. Not exactly what I wanted. Let's grab another problem from your home. Let's look at number 3. It says f of x is equal to x to the 5th minus 6e to the 9x. Find the derivative of that.
We're finding the derivative of that.
Yep. Go. Samira. Thanks for sharing that. I'm here.
Let's see, is it?
Is Jahan here? No. Lois?
Yeah, I'm here.
Yeah, I'm here. Sorry, I didn't hear you.
That's fine. Reggie?
I'm here.
Brianna?
Brianna B?
Yes. Brianna B.
Yeah, I'm
Cameron?
here.
I'm here.
Cameron?
Yeah, I'm here.
Haley?
Here.
All right, did anyone get an answer for this? Jehan? Yes. I got you. 5x to the fourth minus 54. No, to the negative 9x. Tioni, what happened to the 6 that was in front of the exponential part?
Oh, I see.
You missed that? Okay. All right, so let's do this. So f prime of x is equal to, we're going to take this is 5x to the fourth. Same old rules we have looked at for a few weeks now. Yeah, we've got 4 weeks since this class started. Wow. Minus 6 times e to the 9x times 9. Everyone understand what's going on here? We took the derivative of e to the 9x, or u is equal to 9x. So our du by dx is equal to 9. So we kept the original part and we multiplied by the derivative of the exponent. And if you simplify that, that's 5x to the fourth minus 54 e to the 9x. Thanks, Alfred. For the second part, ready to take it up a notch?
That was the answer above. That was the final answer. 5x.
What's that? This is the final answer. Yes.
That was 4 minus 54.
Sure, Nash. Is that good? Nashka, can you see that?
Oh, got it. We're good. Oh, just don't want that.
Okay. All right. Are we all ready for the next one? All right. Let's look at number 7. It says f of x is equal to e to the x squared plus 7x. And once again, we're finding the derivative of the function. Are you guys still thinking about that? Tioni, Baylor,
Here.
Here.
here. That was that. Baylor over here? Okay.
Yeah, here.
Joe? Joe not here. Garen?
Here.
Bill?
Professor, did you Tioni?
I got you, Tioni. Thank you. Jose?
Here.
Jenny? George? You're here. Faith? Faith here. Aaron?
Here.
Don, Damien,
I'm here.
Kat,
I'm here.
Kathy, not here. Kita, not here. They don't want
Here, sorry.
who is that? Who is that saying here? Alright. If it's not noisy in your house, just type in your name, please. Jaren, Carlos, is that your mic?
No.
Oh, I guess you heard me. Alright, did anyone get an answer for this as yet? Makita. And Don says 2x e to the x squared plus 7. Alright, so we're going to do f prime of x. Don answers look good to me. So we're going to have e to the x squared. So our u is x squared. So if we take the derivative of that, it's equal to 2x. So we have to multiply this by 2x. No, we're going to take the derivative of the 7x, which is just 7. Then I didn't get down to your name as yet. So what do we have? 2x e to the x squared plus 7. That's our final answer.
Oh wow.
Any questions on this answer? Minus 2x. Why should it be minus 2x? This is a multiplication symbol here, right? Because you remember the derivative is the derivative of e to the u is equal to e to the u, which is what we have here, times du by dx. The du by dx is 2x, a positive 2x. So all we're doing is times in that by the 2x. Okay with that, Ashka? All right, let's try number 8. It says y is equal to the square root of e to the x plus 1. Kathy here? No. Samuel?
Here.
Thanks, Samuel. Carlo?
I'm here.
Carmen?
I'm here.
New? Not here. Samira?
Here.
Anika.
Here.
Okay. Michael.
Here.
Marta.
Here.
Francis. Alfred. Dashka.
I'm here.
Alden.
I'm here.
Dylan. Dylan here. Martha.
Here.
Transitio.
Here.
Okay. All right, did anyone finish this problem? Any idea how to do this? All right, so what are we doing on this? I help? Rewrite first. And the rewrite on this is e to the x plus 1 to the 1/2 power. So all right, so done. Let's see. What do you end? So y prime is going to be 1/2 times this. We keep the inside, which is e to the x plus 1. And this plus 1 is not on the exponent. And we're going to subtract 1 from the exponent, which makes it a -1/2. All right. And then we have to time it by the derivative of the inside. And the derivative of the inside, e to the x plus 1, is just equal to e to the x from our rule at the very top. It's not there, but e to the x is because the derivative of x is just 1, and the 1 cancels out. So I have to time this by e to the x. So down your answer does look right. So it's e to the x all over 2 times e to the x plus 1 to the 1/2 power. Because of negative exponent, we just moved that one to the bottom. All right, we'll look at a couple more problems. Let's back up. Let's look at number 4 in your homework. Sure, Marta. Is that good enough? I think that's the whole problem. All right, let's look at number 4. It says f of x is equal to x to the 5th times e to the 5x. Find the derivative of this. Joe, are you here? No, Joe. Faith. Any ideas on this?
I got 25x to the 4th times e to the 5x.
Okay, I can see that answer. But you're missing something. Product rule, that's right, Don. This is a multiplication problem. So you have to apply the product rule to this. You know, I tell you, all those rules that we covered before still applies. This is our first, this is our second, right? What the rule says, f prime of x is equal to the derivative of the first, well, the derivative of the first, times the second plus the first times the derivative of the second. Right, that's a product rule. So you have to recognize that the operation, if it was addition or subtraction, then we could go ahead and what you got, Jenny, would have been correct. But this is a product rule problem. So what's the derivative of the first part? And the first part is x to the 5th.
5x to the 4th.
5x to the 4th, right? So that's the first part. And we're going to multiply by the second part, which is e to the 5x. And we're going to keep the first part, which is x to the 5th, times the derivative of the second part. What's the derivative of the second part, which is e to the 5x? Five, and what else? 5e to the 5x. That's correct. This is 5e to the 5x. That's a derivative of this piece. So that's a product rule. You guys cannot forget these rules for the rest of the semester. Now, my MATLAB will probably want you to factor this out. We could factor out, so this is now the left side. And separate it from the right side, you know, with the plus sign. So what's the GCF for this problem? What is common to both sides?
5x.
All right, so there's 3 GCF in this problem. So the first one would be 5. Which takes care of this and this. Now, if we look at the x's, there's an x on the left side and on the right side. X to the fourth, all right, it is. And we always take the one with the lowest exponent. So we took out x to the fourth from the left side, and 4 of the x's on the right side, which means there's only 1 x left. What else can we factor out? E to the 5x. All right, so we factored out this, and we factored out this. So what's left behind to go in the parentheses? X to the 8th. Well, hold on. That's not an 8, okay. Sorry. It was a 5. And what I was saying is, we took out 4 of them, so we only have 1 left. But what about the left side? So on the right side, we're going to have an x left. I agree. What's left on the left side? If we back out everything, what must we put on the left side?
1.
1, right? Remember, we factor out a 5 already, so we can put it back there. So that's the answer my MATLAB is actually looking for. All right, let's grab the next problem. Is actually number 5. It says f of x is equal to e to the 3x over x to the 12. You guys thinking about that? Jaren, are you here?
Yes, I am.
Okay. No Faith today. No Kathy today. New? And Francis, not here.
Yes, I'm here.
Who's that?
It's new.
Where have you been? So quiet. Not because you're ace and everything, and I thought you're taking a day off. So Neil, how are we gonna do this problem?
I'm sorry, but I was having technical issues, so I logged in late.
Can you see the problem on the board?
Yes, I can.
How are we gonna solve this? How are we gonna find the derivative of this?
I'm guessing that we have to use the equation rule.
That would be an excellent guess. Right, so this would be our numerator, and this would be our denominator on the bottom. And if you guys recall, numerator over the denominator, the derivative of that is the denominator times the numerator derivative minus derivative of the denominator times the numerator all over the denominator squared. So same old rules, all we're doing is just putting an exponential function in it. Right, so if we take f prime of x, the first thing we want to do is find, is what? Well, not really find anything. Write the denominator. And the denominator would be x to the 12th power. And we're going to times that by the derivative of the numerator. So what's the derivative of e to the 3x? Three e to the 3x. I agree with that. What do we do now? We subtract. We're just following the rule. We subtract the derivative of the denominator. So what's the derivative of x to the 12th? You sure? 12x? 12x to the
Oh,
11th
that's
power.
the 11. I was on type 11.
Okay, thanks, Samira. And we're going to times that by the numerator, which is e to the 3x. And then we're going to put that all over the denominator squared. All right, so do you think my MATLAB is going to accept this answer? More than likely, no, right? They're going to use a factor the top out. So what can we factor? So once again, we have the left side and we have the right side. And we're looking for the GCF in both sides. So what's the GCF on the top? Can we find a number that's common? What's the GCF for 3 and 12? 3. All right, so the GCF is 3. So we take the 3 out from the front one. And if we take 3 out of the back one, we're left with 4, right? Because we factor out the 3. How about the x's? Can we factor out any of the x's? There's x on the left side and the right side. So how many x's are we factoring out? Always the one with the lowest exponent. So factor out x to the 11th, which takes care of this x to the 11th on the right hand side. And it takes care of, so we only have one x left on the left hand side. What else can we factor out? How about the e's? Can we factor those? E to the 3x. All right, I think that's all we can factor out. So what's left on the left side? Left side, you sure?
1 plus x.
You mean just x, right? There's no 1 plus there,
I meant to say x.
right? So on the left side, we'll have x left because there were 12 originally. We took out 11 of them, so we have 1 x left. On the right side, what do we have left? Don says 4, which I agree with. Because we took the 3 out of the 12, leaving us with 4. And we still have
Oh, okay. I see.
Louis, you okay?
Yeah, I was confused on where you got the 4 from, but I see it's the leftover.
You factor the 3 from the 12, yeah, which left the 4 behind.
Gotcha.
All right, and on the bottom, when we expand that, that becomes x to the 24th power. Unfortunately, it still is not done. What else can we do? We can simplify down. I agree with you. What can we simplify?
The x's.
We can simplify the x's. I agree. So we have 11 x's on the top and 24 on the bottom. So if we cancel the 11 on the top, how many do we have left on the bottom? 13. So we have x to the 13 bottom, which is our final answer. So we have 3 e to the 3x times x minus 4 over x to the 13 power as the derivative of that function. So it wasn't a difficult function from the looks of it originally, but you can see the amount of work involved because of the quotient rule and the simplification. The calculus itself is not that challenging. It's the algebra behind it. This is why they made you guys take intermediate algebra and college algebra before this class. Because all this factorization and simplification is actually intermediate algebra. So hopefully you remember some of that. If not, we're still going over it, so not to worry. Any other questions or comments? Because we're about out